Hi crew! Welcome back to Jamie's Boat Tech Tip tutorial. In this video, Jamie will tell us how to make a DIY homemade water maker that makes 240 liters an hour and only costs $3,000. So keep on watching.
Hi guys, welcome to the video where I will describe my homemade DIY water maker that I installed in Jupiter about 3 years back. Now this is a high output. This puts out 240 liters or 67 US gallons an hour, and it cost me about $3,000 US. I'll describe in detail each component of the system and what's good about it and why I chose it. If you want to skip ahead to that guts of the video, then do so now, 3 or 4 minutes. But first, I want to talk about why do you want a water maker? Why is it important to have one for cruising? We wanted a water maker because we'd like to use a lot more water. When I was carrying water in drums or jerry cans, 20 kilos in each hand from the shore into the dinghy and then into Jupiter, it's backbreaking work. And then you don't want to use it because you're avoiding that work again. However, we were scuba diving in the Philippines and I just wanted to be able to wash out my gear. After a passage, your boat gets covered in salt. You want to be able to hose down your rigging, your winches, your clutches. Another reason, my beautiful girlfriend has long hair. She needs to be able to wash that and keep it looking beautiful. Not to mention showering every day and doing the dishes. Oh, and of course, the laundry. Such a big luxury to be able to have a washing machine on the boat to do our laundry instead of going ashore trying to find someone to do it for you. One idiosyncrasy about having a water maker is that they want to be used, otherwise you have to pickle it and waste chemicals. Doesn't matter how much you're using or wasting really, as long as it keeps working, of course. Obviously if you've built it yourself, you can maintain this thing completely. So that's why we wanted a water maker. When I was looking at options for water makers, most guys were using the 12 volt DC systems, which they were happy to run all day. They're fairly low current draw. You can run them all day. You need to run them all day because they're only about 30 liters or 8 gallons an hour. And they said, yeah, but I can use my solar panels. I'm like, yes, you can, but that means your solar panels are not recharging your batteries, which are also depleted. That wasn't an option for me. And plus, I didn't want to be running something 7 or 8 hours a day. The next option was a larger water maker system, which is either driven by an AC motor or by engine driven pump. I don't have a generator on board Jupiter. I don't want to put a generator on board. It's just another engine and it's heavy. Catamarans don't like heavy. Solution was an engine driven water maker. Now, after Googling around on the internet and reading articles, I've heard whispers of DIY water maker solutions. So I just gathered all the information that I could. And looking at the circuit diagram, they're all basically the same system. So I was able to decide on what output I wanted and then what equipment I needed to do that. Okay, so let's talk about the advantages of building a water maker yourself. Big advantage is that you know how it works. You have an intimate understanding of each component and how it works, and when it stops working you can quickly work out why. So maintenance is easy due to your increased understanding. Remember, knowledge keeps you cruising. The other reason is everybody's hull space is different because we all have different boats. you can put different components in different compartments as need be. Biggest reason, I guess, is cost. You save dollars by doing this yourself. DIY equals save money. Disadvantage, the only one that comes to mind is fitting some components together, whether it is your high pressure pump mating to the clutch in an engine installation, or high pressure pump mating to the AC motor. How to make that happen. Little challenges there. Other little challenges are threads. You've got NPT threads or BSP threads, you know, maybe you're going to need an adapter. So it's handy to build this thing close to a hardware or a bolt shop. So once you've decided how big a WATERMAKER you want to make, what sort of output, that determines the equipment you need to buy. Basically, the high pressure pump is the limitation. And that's the biggest question, is how will you drive the high pressure pump? Some guys have done DIY WATERMAKERs using Karcher high pressure pumps from the car wash machines you can buy from the auto stores, and they do work. They produce 800 psi apparently, which is all you need to push water through a membrane, but they're not made for salt water, so they don't last very long. You might get a year, but I'd be interested to hear from people that have done it with Karchers and how long they do last. I decided on a cat pump. There are cheaper pumps available, but I think it was the most reputable. Cost about half the total cost of my system. Cost about $1,500, including the clutch, the electromagnetic clutch. So mine is in an engine-driven high pressure pump. You can use AC motors that you would belt to your high pressure pump. Then you need to work out how to drive your 1.5 horsepower AC motor. Can you do it from your inverter alone, or are you going to need to have a generator to run? Even the little Honda generator could probably run that. However, mine's engine driven, and that's what I'll describe to you. So from the very start of the flow is the through hull. I decided to use a dedicated through hull that's mostly recommended, so there can be much less chance of flow interruption. Mine is a nylon because I have an aluminium boat, so I keep all my through hulls are nylon or acetal, plastic anyway. My seacock is a simple $3 or $4 screw-on PVC type seacock. All these aluminium boats are using this sort of seacock. You could argue that it's not safe, but we've never had a problem. If you're really worried about it, you can change them out every 5 years, and it's going to cost you about $5. The next in the line is the sea strainer, and I simply used an engine intake sea strainer, which costs $40 or $50. It's just to stop the big particles, seaweed, plastic, etc. After that comes another PVC valve. These again, $3 or $4 each. From there onwards, basically, it's into the high pressure pump. But you need to have a manifold because there's a few different things you want to suck into your system. One of them is the seawater. Another one is freshwater for flushing. So I've used a 1/2-inch poly piping from the hardware with the little irrigation taps that you can buy from the hardware for just $1 or $2. And I've plumbed that into my freshwater system, so it's on the house water pressure system. All I have to do is turn on the little valve, and I have house pressure water going through my system for flushing. I nearly forgot to mention, for the freshwater input, you need a carbon filter. So I've plumbed into my freshwater system, permanently connected to the WATERMAKER, a carbon filter. So for flushing, you may use city water. Maybe you put city water in your tanks when you're filled up at the marina. There's obviously chlorine in that. Chlorine will destroy your membrane. Flushing is best done with your water that you've made from your water maker is completely pure, but more often than not we fill up at the marina when we can. So we need to flush that through a charcoal filter before it goes into the system. And one other input for your system is the pickle. If you're going to leave your membrane for a while, I prefer to flush my system with every 4 days, but if I'm going to leave it longer than that, if I'm going away for a week or two, I will pickle the entire system, which is sodium metabisulfite. I bought that in kilogram blocks. You can buy it from, I think supermarkets may sell small quantities. Home brew shops sell it for cleaning beer bottles, but you want bigger quantities. I bought mine from China, and food grade sodium metabisulfite. I think I bought 5 kilograms of it, and I'm still using it 3 or 4 years later. So yeah, you want a pickle input, and that's simply just a hose with a valve, and you put the end of the hose in the bucket of your pickle mixture when you want to pickle the system. So there are 3 inputs to the boost pump. You simply turn on the one that you're using. Okay, this hosing from the through hull seacock for the seawater to the high pressure pump is 3/4 hosing for this size water maker. That's 3/4 inch hosing. The freshwater and the pickle is only 1/2 inch because they're low flow items. Now the boost pump, I hope I wasn't saying high pressure before, the boost pump, I got this brand Seaflow and I bought it from China. I've seen it online for similar prices that I bought it. It's about $120 to $150 US, far cheaper than the other classical marine brands. And specifically this one is a high output. This is 7 gallons per minute. This one's been on for about a year now and it's been running beautifully, no problems at all. Quick connectors, they don't leak. Been happy with it. In fact, I bought 2 because I thought it was a good price and I wanted a backup pump. Now it's a good idea to protect your boost pump from overheating by installing a fan. And I found the most economical and efficient fan was a 4-inch bilge blower, which I bought for about $30 or $40. And it really generates some wind and keeps that pump cool. And you can wire that to the same switch as your boost pump. Obviously it needs to be rated for a suitable amperage to include the boost pump and the fan. After the boost pump goes into the filtration, the pre-filters. So they're just standard from the hardware. They're 10-inch cartridge. You just unscrew them to change the cartridge. They've got a little bleed valve on top to vent the air out. Starting off with 20 microns, or you could use 10, and the second one would be 5. Next stop for the major component is the high pressure pump. So let's take a look at a video of the high pressure pump installation. Into the first filter, which is a 20 micron. And then the second filter is a 10, I think. Maybe 5. It just depends what I could get in the hardware at the time. And then the hose runs down under the floor. And here it is here, running up under the bilge into the engine compartment where I have engine driven cat pump. I have a model 317 and I chose this pump because it was a higher output, and that's the need for the higher boost pump, 7 gallons a minute, to feed this big guy because it's really sucking and you need to keep positive pressure. So this hose runs down to the input, which is over the back here, and there's the output, and that's the high pressure water. Here is a emergency bypass valve, and you can set that with an Allen key, and I get that just dribbling if I'm about 850 psi. Maybe it's 825 psi. Operating temperature is 800 psi for seawater. This is my gauge to show me the boost pressure. I always like to keep a positive, just slightly positive pressure at the pump face. So there's a 0 here, goes to -30 if there was suction, and it goes +30 to show positive pressure. I'll turn on the boost pump right now and you'll see. So the boost pump provides good pressure. Obviously that will come back to near 0 when the high pressure pump is operating. So the challenge for the engine driven was to mount it. This one is mounted, I'm not sure if you can see down in there, but it's got like an L bracket with a tensioning arm so that we can put tension on the belts. And the bracket is on a piece of angle iron which runs across the top of the 2 engine mount nuts. It needs to be kept in the same sync and vibration as the engine. You can't have the belts leading off to a separate bracket on the side of the bilge, for example, because the engine does a lot of moving, especially during starting. It does a lot of shaking and twisting, and it's just better to have it all in one unit that we've found. So I've just got 2 V-rib belts driving this high pressure pump. This here is an electromechanical clutch, and I will turn it on right now. You'll hear it. And off. So I will turn that on and off as required, and I'll show you that later. As I mentioned, mine's a Cat 317 pump, and this one features a nickel aluminium bronze head, which is suitable for seawater. You can get a stainless steel version, but it's a bit more expensive. Now, things to consider when determining which pump is suitable. The maximum volume or flow rate of the WATERMAKER is determined by the membrane limit. In my case, I've got a large membrane, 4" by 40 long, so if I wanted a perfectly matched system, I would need really a bigger volume high pressure pump, and then of course a bigger boost pump. However, like most of us, we're all limited by space and of course funds. The maximum feed flow rate for the 40/40 membrane is stated as 16 gallons per minute. My boost pump outputs 7 gallons a minute, so I've got a lot of room before I'm reaching limits on this membrane. You need to make a decision on what RPM you want your engine to be running whilst you're making water. Do you want it sitting just above idle, or do you want it at cruising speed? This will determine the size of the pulley mounted on your crankshaft. Use this formula to calculate the size of the pulley. Just prior to the high pressure pump, I have a pressure switch which I bought for $2 or $3 again from China. It's from AliExpress or Alibaba if you can find the low quantity orders there. And it's a normally closed pressure switch, so if there's no pressure, the contacts are closed. When there is pressure, the contacts open. So this will tell me if there's a blockage of the intake, of the filters, or a failure of the pump. If there's no pressure, the switch will close. And I've just got a piezo buzzer that makes a big loud noise to tell me that I've lost pressure, and I can do something about it quickly before I wreck my cat pump. You could wire it, if you wanted to disengage the cat pump. I haven't done that as yet. I'm happy with the audio alert because I'm always on board when the WATERMAKER's running. Next I have just a little T bracket, a T piece and a purge valve. It's just a, again, very cheap little irrigation poly pipe valve, and that's just to remove air from the system before it gets to the high pressure pump. You don't want air going through there. I've only ever had to bleed it initially, like if I've cleaned everything, I've taken it all apart and there's air in the system. Normal operation, I'd never have to bleed it. So that produces a positive pressure at the high pressure pump. Now I know it's positive because I have a gauge there. Now these gauges, this one I bought online. They have to be stainless steel because they're dealing with salt water. And they want to be glycerin filled, not oil filled, because any oil, if it was to leak, would get inside your membrane and destroy it. So glycerin filled. Okay, up to the high pressure pump. As I mentioned, CAT 317, it is driven by engine. It has a electromechanical clutch. So when the engine's at low revs at idle, I turn the clutch on, engages the pump. Then I take the revs up to, I've set my revs to a cruising or motoring speed. About 17 or 1800 RPM is what I would normally motor sail or even just motor on. You can adjust that revs of the engine by varying or by choosing the pulley that you mount on your flywheel or your crankshaft pulley. There's a calculation to work out which size pulley you need to go to this clutch, because it has a certain diameter clutch. You need to choose the appropriate size pulley for the revs that you want to run at. You may want to run it at idle while you're at anchor. You would make water, but I wanted to do it while I was motor sailing. The bracket which the the high pressure pump is mounted on, we had to make a little bit by trial and error, but basically it's on an L-shaped bracket with a adjustable arm so that I can put tension on the V-belts that drive it. That is mounted on a piece of angle iron which runs across the top of two of the engine mounting bolts, the two big studs which hold the engine down. I've just undone the top of those nuts and put that across, done them up, and that keeps the pump, which is quite heavy, I think it's about 20 to 25 kilos, in the same plane as the engine. I've had a friend who suggested mounting it in the hull, and he tried this, mounting it in the hull, having the drive belts run down to this fixed mounting in the hull. But the engine does a lot of moving, more than you realize, like when you're changing revs and maybe at idle it's really wobbling, and during starting it really tilts, and it actually broke his brackets. So this is a much better way. So the engine and the high pressure pump are mounted together basically. From there we have a high pressure hose. This is the only high pressure hose I have in the system. This is where I get our 800 psi. So it's a hydraulic. I got a hydraulic company to swage it up for me. It's stainless steel end fittings. They had to be special ordered. The hose, I think it's 1.5 meters, cost me, this probably was the most expensive part of the plumbing system, the hosing. Maybe $200 US. I can't quite remember. So that high pressure hose goes up to the pressure vessel. The pressure vessel I sourced from China also. I was looking online. I could find a particular model which I found in the States. When I was looking at Alibaba or AliExpress, I found the exact same pressure vessel. So this company in the States obviously just sources from China, so I thought, well, I'll buy from that company too, and I did. As a idea of savings, I got the cheapest price I could find. A 4-inch 40-inch long pressure vessel in the States was about 1,500 US. I got this one for 600 US, so nearly 3 times cheaper, and perfectly happy with the quality. I mean, you must be careful when you buy from China. You can't know what you're going to get all the time, but out of a lot of things on this boat I've bought from AliExpress, there's only been 1 or 2 out of perhaps 30 purchases that I've been not happy with, and I have told them I'm not happy with this, and they've given me an immediate refund. I don't even need to return the product. So I've been really happy dealing with them. Often it's hard, the communication though. You may not, their representative, their sales rep may not have good grasp on English. The other end of the pressure vessel, I have the pressure regulating valve, which is just the needle valve. Very simple piece of kit. I got mine from China. It's 304 stainless steel. I took it in to have a fitting, an adapter ring put on it for at the hydraulic shop, and the guy there in Australia, he said, wow, nice bit of kit, this stainless steel, wow, and it cost me $20. I've got 2, one for spares. This is where the pressure regulating valve goes, and you will also need a pressure gauge there. I got this one. This one must be stainless steel again, and not that critical, but I got glycerin filled again, not oil. Not critical, so again, not critical because it's downstream of the membrane, but who knows, you know. After the pressure valve, after the needle valve, is low pressure. Now you can go back to your cheap poly hosing, which I've used, just irrigation, the black poly hose, using all the elbows and T's and their joiners, and I get the occasional drips, and I can try and replace them, but I am chasing drips occasionally now and again, and now I've just sort of given up chasing the drips. I just accept there's going to be a couple of drips into the bilge. There's no big deal. So after the pressure regulating valve goes to my flow meter. Now this is brine. This is the wastewater, and I don't need a flow meter there, but I wanted one because they were $8 each from AliExpress, and I just want to measure the ratio of brine to product water, and that'll give you an idea of the efficiency and the condition of your membrane. Brine, or the reject water, comes through here, flows behind there into this flow gauge. This tells me the brine flow, and I can just keep an eye on the ratio of fresh water to brine, make sure the efficiency is still good. This goes out through here and overboard. There's a through hull over that way. If I want to, I sometimes flush acid or alkali through for heavy cleaning, and I put this one into a bucket, and then I can keep flushing a circulation of acid or alkaline cleanser. Product water is coming out the end of the pressure vessel, and it is also low pressure, and this is low pressure. So it goes through this flow meter, and this is where I read how much water I'm producing, and that goes to my sample pipe, which is open right now. So I normally have to run the machine for 1 or 2 minutes. I have the sample hose here, then I measure the TDS, the total dissolved solids. Once it's satisfactory, which is normally within a minute, I get, as long as I'm happy with less than 400 parts per million, but I prefer 300. Then I can open this valve, which goes straight to the tank. And once I open that, I turn off the sample. If you got a lot of money, you can use like a Y diverter valve here, but I couldn't find anything that was reasonable price. Just got to make sure when it's running you don't turn both off, because then something's going to blow up. So open and then close. Okay, so in a nutshell, that is my DIY water maker on Jupiter 2. I just wanted to comment on reverse osmosis water for consumption, for drinking. It's not that healthy for you. It is devoid of minerals, and we need our minerals to keep our electrical systems working from our brain to our body. So you need to supplement. So in our drinking water bottles, I add some of this product, if I can get it. It's from a health food shop. It's mineral drops. Just add a few drops to your drinking water. And also make sure that you're using Himalayan rock salt or sea salt, which has got a variety of minerals, as opposed to the iodized table salt, which has only got sodium chloride. So that should keep you healthy. So remember, knowledge keeps you cruising.